I'm audible to everyone, right? Tell me everyone, I'm audible. I'm clearly audible, right? Okay, very good. Okay, so 7.1 in class exercise. This is 7.1, right? In class exercise, level 3. I guess we have discussed this 7.1 in class level 3. We have discussed already, right, everyone? Just let me know. We have already discussed this level 3. We have discussed some problems of level 3 already. Yes? Tell me, everyone. How many of you remember? We have discussed this. Ronak, remember? Very good. Okay. Next. So these two questions we have discussed already. Okay, that was homework, right? This one also we have discussed. If you remember, this one also we have discussed, right? So 7.1, 7.1, yes, 7.1, I guess. Level 3 was already discussed. Okay, yes. William also says yes. Okay, very good. So 7.2. In class exercise, level 3. So we haven't discussed this one, right? Now when you talk about 7.2, okay, so what do we have here? Just see, what do we have here? The partial pressure of CO2, the partial pressure of CO2 in air saturated with water vapor, okay, right? Is 1 atm, is 1 atm. And 1 atm is 3 into 10 power minus 4 atm. So what is given? Wait, everyone. What is given? First of all, write down whatever is given. Okay. So what is given? We have water vapor at, I'll just tell you, right, what to do. Okay. Because again, I'm not facing the same issues. Now, here's Henry's law. Okay. Henry's constant is given and partial pressure is given. Can you find the concentration? Tell me yes or no. Using formula, partial pressure is equal to Kh into concentration, or concentration is equal to Kh into partial pressure, depending on the unit. Depending on the unit, which unit we are using, right? So here the unit is mole per liter per atm. Mole per liter per atm. So obviously, it will be concentration is equal to Kh into pressure, right? Yes or no? Tell me yes or no. Which formula of Henry law we have to use? Either it is C is equal to Kh into P, or P is equal to Kh into C. It will depend on this unit of Kh. So a unit is mole per liter per atm, which is, tell me, now mole per liter per atm. So if you see the dimension, right, it will be the formula, right? Tell me yes or no. Yes or no. So I can say that solubility. So because concentration you asked, right, which is solubility. So solubility is equal to Kh into P. Yes or no? Tell me. Yes or no? Okay. So solubility we will get here. Wait, I'll just S is equal to Kh into P. So from here, from this Henry's law, I'll get solubility. Agree, everyone? Now, what we have to do, obtained as CO2 get mixed with water, right? And its pK is given. Now, H2CO3 is mixed with water. So if you find the solubility, right? If you find the solubility, see this. It is 10 to the power minus 2. It is 10 to the power minus 6. If you multiply this, sorry, 10 to the power minus 2, 10 to the power minus 4, it will be of the order 10 to the power minus 5 or 10 to the power minus 6. Yes or no? Tell me. Yes or no? And 3.33 into 3 is nothing but 10. So solubility is 10 into 10 to the minus 6, which is 10 to the minus 5, right? And H2CO3 is a weak acid or strong acid? Tell me, everyone. H2CO3 is a weak acid or strong acid? Weak acid, right? Agree? So what is the formula for concentration of H plus? Tell me, what is the formula for concentration of H plus? Tell me. Root K into C. Into C. Agree? Tell me yes or no. Yes or no. But again, before using this, you have to find alpha. Alpha is equal to root kh by c. Sorry, k by c. Okay. So if you calculate this, right? So it will be root will not be very less than 1. Yes or no? Tell me, everyone. It will not be very less than 1. So for this, okay. Wait. Sorry. I just got this one. Sorry, my bad. I just saw the Ka of 10. Okay, pK is 6.37 is given, right? Which is very less. Okay, it's 10 to the minus 7. So you can use this formula directly. Okay, sorry, my bad. I just saw this as a K. Okay, so you can just use this formula directly, right? You can also find alpha, right? So alpha is less than 0.1 because it is 6.37, right? So it is 10 to the minus 7 something. Okay, so obviously it will be less than 0.1. Okay, so we can use this formula. Got it, everyone? Tell me. Question number 9, got it? Yes or no? Tell me, everyone. Yes or no? Okay. Now question number 10. Everyone just see question number 10. So what is the pH of 1 molar solution of acetic acid? 1 molar solution of acetic acid, right? K is given. So tell me, ideally what you have to do. Now, can you use formula over here? Tell me, can you use formula over here? Which is pH is equal to half pK minus log C? Yes or no? Just tell me. Yes or no? Can you use formula over here? Guys, tell me. See, as I told you, right? Okay, 1 molar acetic acid, which is not very less. So alpha root K by C, alpha which is root K by C will be less than, very less than 1. Yes or no? Right? So yes, you can use the formula over here. Okay, so you can just use formula. pH is equal to, tell me, half pK minus log C. C is 1. So log 1 is 0. So it is half pKa. As simple as that, right? Half pK. Okay. Okay, everyone. Now, Next, approximately what volume must be added to 1 liter of the solution so that pH of the resulting solution will be twice the original solution? So see, so I can say that 2 pH old, 2 pH old. Guys, wait, I don't know why my writing pad is not working again. Whenever I take pure class, it doesn't work. So basically 2 pH old is equal to pH new, right? So we know that pH old is half, right? So you can just say that pH old, wait, okay. So pH, 2 pH old, so I'll just write as 2 pH is equal to pH dash, pH dash, okay, which is pH new, right? Now we know that this pH dash is equal to half pKa, half pKa minus log C. Now this C is new concentration. Okay, this is new concentration. And this old pH is nothing but half pKa, right? So half of it will get cancelled. It is just pKa. pKa. Okay. So you can find C from here. You can find C from here. Okay. Now C is what? Tell me. Number of moles will not change, right? Number of moles will not change. So if, got it? So C will be number of moles by new volume V dash. Okay, got it? So V dash you can calculate because number of moles will be same. Okay, tell me yes or no. Tell me, got it? Getting this? Okay. Okay, very good. Now homework level 3. Wait. Homework level 3 we have discussed, I guess, right? I remember discussing this. Guys, tell me. We discussed homework level 3, I guess, already. Yes or no? Oves, Aryan, have we discussed this? Because I remember discussing this. Right? Very good, Samya. It's discussed. Very good. Okay. So 8.3. Okay, 8.3 level 3. So in this, I can say that, first one, just go through the first problem, question number 8. Read question number 8, guys. I don't know what's the issue. Issue is with my laptop or issue is with my this. Okay. I don't know what's the issue. Okay, so question number 8. Everyone just go through question number 8. So we have 20 milliliter of 1 molar sodium hydroxide. So number of moles 20 into 0.1 is added to 20 milliliter of 0.2 acetic acid. Now tell me, strong strong base and weak acid. Strong base, weak acid will give me what? Tell me. Strong base, weak acid will give me what? Salt of strong acid and yes, salt of strong acid and weak base. Very good. So if you calculate, so I can say that this is 6 millimoles and this is 2 millimoles. So we can say that we will left with 4 millimoles of weak acid, 4 millimoles of weak acid and 2 millimoles of salt of weak acid. Yes or no? Tell me. Yes or no? Yes or no? So I can say that pH is equal to half pKa, just pKa plus log salt by acid, right? Salt is 2 by acid is 4, but the question is calculate the addition volume of 0.1 molar NaOH. Okay, 0.1 molar NaOH. It means 1 into V into V. So it is now if base is added, right? Salt concentration will increase. So it is plus 0.1 into V, and acid concentration will decrease. So minus 0.1 into V. Now pH is given, pK is given, right? So can you calculate the value of V? Tell me yes or no. It's just formula putting getting. Tell me guys. Okay, calculate that the pH of the solution is this. pH is 4.74. Okay, right? pH is 4.74. And what is pK? pK is also 4.74. Yes or no? Right? Because it is 5 minus 0.26, which is 4.74. So pH and pK are equal. So this is equal to 1. It is not that difficult to calculate. 2 plus 0.1 V by 4 minus 0.1 V is equal to 1. Okay? Got it, everyone? Just raise your hand. If you got this, just raise your hand. 8-1. We have solved this kind of problem example. Okay, very good. Next, question number 9. So PKB is given. Calculate pH when 100 milliliter of 0.1 NH3 solution is 50% utilized. Now tell me, if 50% utilized, if you can say 50% utilized, then what is the concentration ratio of salt and acid? 1:1, yes or no? Yes or no? Tell me, right? So what is log 1? Log 1 is 0. So can I say that pH is equal to pKb? Sorry, pOH is equal to pKb? Can I say pOH is equal to pKb in this case? Right? So what is pH? pH is 14 minus pKb. So 14, first one is 14 minus 4.74, as simple as that. Now it is 100% utilized. Then it's easy, na? If it's 100% utilized, then what? Tell me. then it's just the concentration, right? Then you don't have to use any formula. It's just the, tell me, strong component, right? Okay. Just calculate the concentration of H plus or OH minus. Next, this level 3. Now we will start with, okay, question number 10. Everyone just go through question number 10. It started working. I don't know where, how come. It's not working now. Okay. So what are the concentration of, see, I guess all of you can solve question number 10. We have already solved a problem like this. Yes or no? Tell me. Yes or no? Because when you talk about this, this is strong, right? This is considered as weak. Okay. Right, everyone? So concentration of H plus, right, will be same as concentration of H plus in both. Yes or no? Tell me, everyone, yes or no? Okay. So I can say that in this case, if you see, right, that this H2SO4, when it breaks down into H plus plus HSO4 minus, it behaves as strong acid, which means the concentration of H plus should be equal to concentration of H2SO4. Yes or no? Yes or no, everyone? And what is concentration of H2SO4? It's 0.02 molar. So concentration of H plus is already given, which is 0.2. Okay, right? Now, second one is weak one. So we have to worry about second one. So H3O plus is H plus concentration, it is 0.2 as well as that, right? Using common ion effect, or it will be something more than that, right? So let's see, right? Let's see what is happening. Okay, so let's see. Second one, K is given. Yes or no? K is given. Concentration of H4 minus is given. Concentration of H plus is equal to what? Tell me. Tell me, everyone. Tell me. C. It will be what? C. This is C, because it will break down into equal components. So C bracket 1 minus alpha, C alpha, C alpha. Right, everyone? Tell me, right? Okay, but this H plus is already present, so it will be C plus C alpha. So concentration of H plus is C plus C alpha. Yes or no? Tell me. Using common ion effect, C plus C alpha, and K is equal to what? Concentration of H plus into concentration of SO4 2 minus, divided by concentration of HSO4 minus, which is C bracket 1 plus alpha into C alpha, whereby C bracket 1 minus alpha. C will cancel, right? Now, since K value is very, tell me, K value is not very small, right? So we'll have a quadratic equation. and solve quadratic equation, you will get the value of x, then you will get the value of everything. Yes or no? Tell me. Yes or no? Got it? Question number 10. Tell me everyone. Did you get the concept? Okay, very good, right? So the concept here was, since the value of k is not very small, you will not ignore C alpha in common ion effect. Okay? Okay, everyone. Now let's see. Question number 11. pKb of weak base is given. In what amount should 0.02 molar of this base and 0.02 molar of HCl? See this, right? Weak base. Write down the information. Weak base pKb is given. pKb. POH is equal to pKb plus log salt by base. Remember this, right? Now, POH is given because pH is given. So if pH is given, POH is also given. Yes or no? So POH is, tell me, 14 minus 7 is 7. It's neutral. pKb is 7.3 plus log. Now, question was, in what amount should 0.02 of this base and 0.02 molar HCl must be mixed to have 4 milliliter of buffer salt by base? Now tell me, weak acid will react with weak base will react with strong acid to form what? Tell me, to form what? Salt, right everyone? Yes or no? Yes or no? And we know that suppose the volume of this base is X and the volume of this acid is Y. So total volume is 400. So X plus Y is equal to 400 we know. Okay. So X is equal to 400 minus Y. Now see this, the concentration of this is given. So number of moles of base is 0.02 into X. Number of moles of acid is 0.02 into, tell me, 400 minus, 400 minus X, Y is equal to 400 minus X, that's right, X, right? Now, just put it. Can you solve the value? Tell me, it will be linear equation one variable. Yes or no? Tell me everyone, are you getting this concept? Yes or no? Okay. Please raise your hand if you're getting this concept. Please raise your hand. Okay, next. Question number 11 clear? Next, question number 12. The first ionization constant of H2S is given, right? Calculate the concentration of HS minus. Okay, again. So H2S, I can say that H2S will break down into H plus plus S minus, right? HS minus. H2S will We are into H plus plus HS minus, because it is specifically mentioned that we have, for this K1 or K1 is equal to concentration of H plus into concentration of HS minus divided by concentration of H2S. What is given? Right? This is the formula that we know already. What is given? K1 is given. Calculate the concentration of HS minus in its 1 molar solution. 1 molar solution, and how it will be, concentration will be affected. Okay, so first it is buffer. First thing, it is buffer, right? Because weak acid, salt of weak acid. Okay, weak acid, salt of weak acid, right? Now I can say that in the presence of 0.1 molar HCl, tell me, in this case H plus will be produced by this, yes or no? Yes or no? Tell me everyone. Right? So K1 is given, which is 9 into 10 power minus 8. It's equal to concentration of H plus is 0.1 into concentration of HS minus that you have to calculate. Concentration of HS minus that you have to calculate, divided by 1 molar solution. So concentration of HS, okay? Concentration of HS is given, which is 1. So HS minus concentration easy. Tell me, yes or no? Yes or no? First part clear? First part clear? Okay. Now second part. If the second distillation constant of H2S is given. Now see, second distillation constant is this, right? Okay. So we know that from first ionization constant, right? You can just say Ka2 is equal to concentration of H plus into concentration of S2 minus divided by concentration of HS. Yes or no? Yes or no? And I can say that since the value of this is very less, can I say that concentration of H plus and HS minus is almost equal? We have done this already in previous examples. Yes or no? Tell me. Because it will be C plus C alpha and C minus C alpha. Now, since this value is very less than Ka1, right? 10 power minus 5 times less. So you can ignore. So Ka2 will be just concentration S2 minus. We have already done this. So done this. Tell me yes or no, everyone. Tell me. If you remember, we have done this. So concentration of S2 minus will just be equal to what? Ka2. Yes. Okay. Now this is when, right? This is when we don't have HCl, right? When we don't have HCl, that's why we are canceling it, right? But if we have HCl, then in that case, the concentration of H plus will be just 0.1. Yes or no? Yes or no? And concentration of HS minus we have calculated already. Okay, so you have to put that. Okay, everyone. So there's a difference. Yes or no? So in the absence of, because we have both conditions, right? S2 minus is same as Kb, right? But in presence of HS minus, sorry, presence of HCl, you will use HS minus concentration that we have calculated from the first one, right? And constant H plus is 0.1. Okay, so it will be Ka2 is equal to 0.1 into concentration of S2 minus, whereby now this we have calculated from Ka1, which was Ka1 into 1 divided by 0.1. right? Okay. Now question number 13. Calculate the concentration of all species. Okay. See this. K1, K2, K3. K3 is very less than K2, and K2 is very less than K3, right? So you don't even have to solve anything. Agree, everyone? Tell me, agree? So let's see, right? First we'll try to solve, then we will think. Okay. Now, if we think about this first one, K1. So K1 will be H3PO4 gives H plus plus PO4 H2PO4 minus. Agree? Right? So now first one, right? If you can see that, it will be X plus Y plus Z. But Y plus Z will be very less as compared to X, because K1 is very, like K1 is more than K2 and K3 to 10 power 5 times. Okay. So if it is C, it will be C minus, okay, it is 0.1 already. So it is given 0.1 minus X. So it will be X. Now, technically it should be X plus Y plus Z from second plus third, but Y plus Z will be very less as compared to second. So we'll just ignore this. Okay, we'll just ignore this. So from this reaction, can you calculate the concentration of H plus and concentration of H2PO4? Tell me, yes or no? Right? Yes or no? Tell me, everyone, which is basically K is equal to X squared, thereby 0.1 bracket 1 minus X into, yeah, 0.1. Sorry. This is 0.1 minus X, not 0.1 into 1 minus X, right? So from here you can calculate X, yes or no? This is a lengthy question, right? You have to calculate a quadratic equation. K1 is already given. So from here you can calculate X, which means concentration of H plus and concentration of H2PO4 minus. Then the same way you have to do for K2, concentration of H plus is already PO4 2 minus, HPO4 2 minus, right? Will be calculated in the same way, okay? And the same way for PO4 2 minus. So it is a lengthy process, right? I told you how to solve. You have to solve 3 linear equations, quadratic equations. So that is lengthy process. Question 13 is quite lengthy process. Are you getting how to solve this at least? Question 13, it is an advanced problem. That's why it is lengthy. Concentration of H plus and concentration of H2PO4 minus can be calculated after finding the value of X, right? Now, after you find the value of X, the second equation is this: H2PO4 minus gives H plus plus PO4, HPO4 2 minus. Now, this is X minus Y. Now, this is X only, right? Because Y will be very less than this. And this is Y. X we know already. So, can you calculate K2 is equal to X into Y by X minus Y? Tell me, yes or no? Yes or no? Now, as I say that, this Y will be very less than X, right? So, X will get cancelled. So, Y will be just equal to Ka2. The concentration of this HPO4 2 minus will be equal to Y, which is equal to Ka2. In the same way, you have to do for Ka3. Okay, right? So, we're done with this. Then 8.4. 8.4, question number 9. Everyone just go to question number 9. 8. So buffer solution will give me what? Tell me. Buffer solution give me what? Concentration of OH minus. I hope everyone remember we have solved many problems like this. So this buffer solution will give me concentration of OH minus. Tell me yes or no. Right? And what is concentration of OH minus? It is basically Kb into, tell me, concentration of, tell me, base. Here base is what? Tell me, ammonium hydroxide, right? Ammonium hydroxide. Okay, so by salt concentration is how much? 0.25, and Kb is also given. Kb is 2 into 10 minus 5. Can you calculate concentration of OH minus? Yes or no? Yes or no? So obviously, if you get the concentration of OH minus, you can easily calculate the solubility of X and Y. Yes or no? Tell me, guys, are you getting? Because KSP, let it be KSP1. KSP1 is equal to concentration of X into concentration of OH minus whole square. So concentration of OH minus you will get from here, and concentration of X minus you will get from this equation. In same way, you can find the this. Okay, I hope most of you got this. Now this one. Question number 10. Okay, question number 10. The information what is given as usual. Solubility of MgOH voltage in pure water is given. Okay, S in pure water is given. This is S in pure water. Okay, calculate the solubility in 0.02 molar MgNO3 voltage. Again, what do you think? What is this? Common ion? Yes or no? Yes or no? Yes. And this is okay, and this is gram per liter. So you can calculate in mole per liter, which is 8.7 into 10 to the minus 3 by 58 mole per liter. Okay. Now, OH voltwise will give what? 2 mg, 2 plus 2 OH minus. So if it is X, sorry, yeah, wait, it is 1 mg, my bad. If this is X, this will be 2X. Okay, now initially it is said that this is given, X is given, right? Okay, so initially concentration of Mg2 plus is given, which is 8.7 divided by 58. So into 10 to the minus 3. So if you take it as 10 to the minus 4 and 87, so you will get this closely approx. Tell me, this closely approx 1.5. Concentration of Mg2 plus is 1.5 into 10 to the power minus 4, right? X, the value of X. And concentration of OH minus is twice of this. So concentration of OH minus is equal to 3 into 10 to the minus 4. Okay. Now, next question is given as calculated solubility in 0.02 molar MgNO3 voltwise. So concentration of Mg, new Mg. This is concentration of new Mg now, right? Okay. And you have to find what? KSP, new KSP. So KSP, right, is equal to what? Concentration of Mg2 plus into concentration of OH minus. Now, a whole square. OH minus is this one, Mg2 plus is this one which is given. Sorry, this one which is given. Okay, right? Tell me, got it? Got it, everyone? Okay, so that was question number 10. Now question number 11. 11 we have done, right? I think that we have done this almost same problem in example. Tell me, everyone. Almost same problem example we have done, where k is equal to k. In that problem it was kh, right? So k is equal to kh, sorry, ksp by k square, something like that. How many if you remember that? Tell me. How many if you remember that? So isn't it the same? Almost same. So let's see what we will do. First, what is the reaction? Okay, everyone. So the reaction is what? Benzoic acid, and KSP of silver benzoate is this. So CH3, COOH, right? And CH3, COOAG. So this will divide into, this will break down into CH, sorry, it's C6H5, sorry, C6H5, C6H5. So I'm just writing C6H5 Ag will break down into C6H5COO minus plus Ag plus, right? Okay, and again C6H5COOH break down into C6H or 5COO minus plus H plus, right? We have these two reactions. Tell me yes or no for this Ka. Okay, right? Right, everyone? Now, what reaction is happening over here? The ionization constant of this, okay, so this ionization constant is given, which is K is given. Okay, how many times is silver benzoate more soluble in buffer? Pure water. Okay, okay. So what will be the reaction? What will be the reaction? Tell me. What will be the reaction over here? If you're mixing this and this, what will be the reaction? See, the reaction would be this one, right? The ultimate reaction would be C6H5 COOAG, right? Will react with H plus because C, right? It will react with H plus and give what? C6H5 COOH plus Ag plus. It will give this one, right? Now, this is the reaction that we need. This is the reaction that we need, K dash. Now, how can we write K dash in terms of KSP and K? Tell me, how can we write K dash in terms of KSP and K? Can you anyone tell me? Anyone tell me? Can we write K dash is equal to, see, if you just reverse this reaction and add, right? So I will get this reaction. So it will be KSP by K. Agree, everyone? Agree? Yes or no? Yes or no? Tell me. This is same as the one that we discussed in class. In that case, it was KSP by K square. Okay, so I'll just rub everything. So K, sorry, K dash is equal to KSP by Ka is equal to concentration of Ag plus into concentration of CH3COOH whereby concentration of CH3, sorry, C6H5, sorry, my bad, COOAG. Okay, right, everyone? Tell me yes or no. So what is given, what you have to find? This is the formula now. Okay, so if you see the reaction, this concentration, this K is given, KSP is given. How many times silver benzoate more soluble in buffer of pH? Now pH concentration H plus is given. Okay. Okay. So I can say that, right? Sorry, everyone. So K dash is equal to KSP by Ka is equal to, now this is concentration of this CH3COH, right? Yeah. Okay, CH3COH. So if it will be C, it will be C X X C minus X, or wait. No, it because see, it is CH3COO minus. Now, don't you think that the concentration of CH3COO minus will be same as concentration of H plus? Tell me yes or no. Almost. I'm not saying exactly, but almost. This question was a bit difficult, right? It is difficult because we have to solve one more problem like this now. So concentration of CH3COO minus will almost be equal to concentration of H plus. Okay. X squared divided by concentration of H plus, right? Because concentration of CH3COO minus is almost equal to concentration of H plus. Now concentration of H plus is given, which is this one, this 10 power minus 3.19. Again, it is a difficult problem, right? Okay. Value of X, you can get the solubility. Okay. Okay, everyone. Tell me, yes or no? This is difficult. I know this is difficult to understand. At least you guys are getting the method. Tell me, we have discussed one problem in class also like this. After finding X, right, can you calculate alpha or solubility, which is divided by total concentration? Tell me, everyone. See, from here you can get X. Now what is being asked? How many times silver benzoate more soluble in buffer of this compared to solubility in pure water? For pure water is easy, right? For pure water, Ksp is equal to S squared. Yes or no? So you can calculate S from here, right? For pure water, and then buffer, that is X. You have to find the ratio of X by S, as simple as that. Okay. Now question number 12. Solid AgNO3 is a. Now question number 12, I guess everyone can solve. Yes or no? Tell me. Question number 12. Find Q. We have solved a problem like this. An example. How many of you remember this? Tell me, how many of you remember this? MnCl, MnS, right? Exactly same problem like that. Yes or no? Tell me. Right, everyone? About percentage, right? So just calculate the concentration of I minus from Ksp because concentration of Ag plus is given. Okay. Ag plus you can calculate to precipitate using Ksp. So this is the same problem that we have discussed in class. Instead of MnS, MnCl, MnI, it is given AgCl, AgBr, AgI. Okay. Okay. So we are done with this. Now tell me, how many of you given the major test? Sorry, advanced major test? Just raise your hand. 1, 2, 3, 4, 5, 6. Meet, have you given? 7. Okay, chemistry. So we will just discuss the doubts. Okay, we will discuss only the doubts. Okay, Aryan. So question number 19, any doubts? Tell me, question number 19, any doubts? I guess 19 was easy. Right, everyone? 19 should be easy. 19, everyone could have solved. Let's just calculate using the formula number divided by Na. What problem? Abhiram, this is perfectly correct question, right? See the first word, hypothetical in universe, right? So you have to see that this is the quantization of which smallest number. You have to find the HCF of all the numbers. Okay, will give you the smallest charge. Okay, so in this hypothetical inverse, the charge of electron is not 1.6 10 to the minus 19. Okay, got it? So this was perfectly fine question. And the first word clearly says that it is hypothetical universe. So obviously charge of electron 1.6 you should not take. Okay, next. Next, which question? Tell me. 2021. Okay, 20. A sample of natural gas is 80% methane. No, this is easy, right? This is easy. Now, if it is 80% methane, right? So you, right? So I can just assume in 100-gram sample, in 100-gram sample, in 100-gram sample, 80 gram is methane and 20 gram is ethane. So number of moles of ethane and number of moles of methane you can find, right? Got it? Tell me yes or no, right? Then mole fraction of ethane you can find and mole fraction of methane you can find. Yes? Yes, everyone? Now, how can you find density? Just think about it. Just think about it. What is the formula? It is given, pressure is given, temperature is given. What is the formula? PM is equal to dRT, right? So partial pressure P1 into molecular mass is equal to density into RT. So mole fraction is given, total pressure is given. Can you find partial pressure? Yes or no? Yes or no? Right? Okay. So you can just use formula and you can calculate the density. This formula been getting PM is equal to dRT. Okay. Next, 21. A 15 milliliter sample of 0.2 molar acid react with Na2CO3. See this. Now, acid you don't know, right? But we know that any acid, right? It might be monoacidic, diacidic, triacidic. So it will be, suppose HXA, right? HXA. It is reacting with Na2CO3. Now this is excess. So H2A is a limiting reagent. Okay, right? Now you just have to see what is the total number of moles of acid. It is 0. Tell me 0.20, 0.250. It is 10 millimoles. And CO2, right? How much of CO2 is produced? So you can calculate number of moles of CO2. Precious volume is given, right? So PV by RT. Calculate total number of moles, right? Okay. Now just by seeing the ratio, you can calculate. Okay. If someone is saying 0.005, so it is millimoles, and moles it is 5. Okay. So the ratio is 2:1, 2:1, as simple as that. Okay. Next, after 21. After 21, 22, 23 are theory, I guess. 24 also could have been done easy. 24 was easy. 25 done in classroom. 27, okay. Now think about this. What is assertion 1? You discover an element that have 5 electrons in its atom. Now see this. All the aspects are same, right? Only atomic orbitals are different, okay? So let's see, you discover an element Z that have 5 electrons in the atom, which form, okay? So it can take 7 electrons, yes or no? Yes or no? Okay. Now, in this, you find the first location energy, if you 3 electrons. Now, don't you think that we have S and P? In S, right, in S, we have 2 electrons. And in P, we have 3 electrons. So one atomic orbital can hold only 2 electrons. But if 3 and 9, so one atomic orbital can hold how many electrons? 3 electrons, right? So if this is true, then 5 plus 7, 12, 3 plus 9, 12. It's also true, right? It is, the configuration is what? 2s3 and 2p2, right? So since it can have 9 electrons, it can get 7 more. Right? A correct explanation. Got it, everyone? Tell me, got it? Yes? 27? Abhiram, got this? Okay, sorry. The answer, okay, yeah, my bad. It is can have. Okay, that's the English, right? You discover elements that have 5 electrons atom which have, okay, sorry, my bad. Sorry, yes, sorry. Right? It might be can, because if we have 1s2, sorry, 1s3, 2p2, it will prefer to lose 2 electrons, right? Tell me, it will prefer to lose 2 electrons. Okay. So it will have plus, tell me, it will have plus 2 charge. I was just seeing assertion by can, okay? Right? If it would have been can, then it's true. But it is said that has, okay? If right, it would be can have charge of -7, then it's true. But it is saying that it has charge of -7, right? Which is not true because it is +2, right? It is better to lose 2 electrons than to gain 7 electrons. It's like that, okay? Okay, next. Next is integer type. Tell me. $29, okay. So it's formula putting it, na? Right, everyone? Tell me, yes or no? VRMS is equal to root. Batao. Calculation mistake then. How many of you got 0.3? Anyone who got 3? See, again, it's a calculation, right? You just have to check the calculation again, right? See the solution. What was the error? Okay, if it's 0.3 and if there's error in calculation, then you're correct. As simple as that, right? Okay, I'm just talking about the conceptual mistake. Don't worry about the calculation mistake, right? You just have to see. If you guys got 0.3, then it must have been a, okay. Who else got 0.3? Just check once more, na? Check the solution and see if they have made some mistake. Okay, right? You can just assume that your marks is 3 more marks. Okay, next. Any more doubts? 31. See, HC by lambda is given. HC by lambda is given because this is given. Okay. Now, electron is ejected. We know that HC by lambda. Got it? Tell me yes or no. Right? Yeah, Viram, matrix match options was not there. I know, right? That's why you just leave matrix match. Voice is breaking. Voice is clear. It might be your internet, guys, because my internet speed is very, like, very good. Yeah, yeah. Okay. So kinetic energy is given already. Yes or no? Kinetic energy is also given. Tell me, you asked to find phi work function. Can you calculate this? Tell me, everyone, can you calculate this? You just have to calculate the work function now, as simple as that, right? Again, this is calculation Pranjal, right? This might have been calculation error, right? Because concept wise it is easy. Okay, tell me, concept wise this problem was easy. You just have to find work function, right? And just check with the form this formula. Okay, match, yeah, because of some bug, okay, which cannot be resolved now. Okay, matrix match answers are not there, so obviously your marks will be, like, I will consider your marks out of how many marks? It is of 8 marks, I guess, right? So see, for this, if you are scoring around 50%, it's good enough marks, right? It is actually your around 60%, right? So 50% is always good enough marks. Okay, minimum you should score around 25% plus. Minimum 25% plus, right? 50% plus is good. Okay, right? So considering the matrix match one, right? It is of suppose 220 marks. 72. Okay. That's what I'm saying, right? So it's basically, if you remove this, yeah. So what we can do now tomorrow from next time is matrix match. You can just write in the paper, okay, right? Matrix match you can just try to, or I'll just do another thing. Okay, I'll just do another. I'll take this exam on Google Form, right, for matrix match. Okay, okay, everyone. Okay. See, if you're getting more than 60, it's good. Okay, try to get more than 60 at least, right? Because including paper 1, paper 2, you should get more than 120. Including paper 1, paper 2, you should get more than 120. Okay? Okay. Okay, everyone. Thank you. Bye. So in this paper, if you're getting 100 plus, that's a good score. Okay? this is the first exam, no, Aryan Abhiram, right? So as I said, right, the highest in this test is around same 150, 160 only, right? So 120 plus is a good score, okay? But from next time onwards, right, I will just write down the, I'll share the form, Google form, in that write down the matrix match, okay? Bye everyone, take care. Bye everyone.